Okay, let's make a start. Just give me a minute. I'll share my screen. I hope all of you can see my screen. So today we are, first of all, I would like to sorry, I'm having a glitch on my computer. I'm trying to move. So first of all, warm welcome to all our attendees. My name is Balvinder Dang. I'm the founder of Datavid. We are a niche consultancy focusing on building data applications. We specialize in NLP and semantic technologies, both open source and proprietary technologies like MarkLogic. So today's webinar, we are going to discuss practical applications of semantic and machine learning technologies. So let me skip this slide. So I'm just going to introduce our presenters first, and then we'll get going. So the first session is by Graham Mullier and Malcolm Tone. They will be talking about how in Syngenta they have built an application which acts as an information asset and supports innovation through semantic search. And the second session is by Mehdi. He's a principal solutions engineer at MarkLogic, and he'll be showing us how building knowledge graphs using smart logic and MarkLogic together. So I'll hand over to Graham now and Malcolm, and they can start presenting their.
Brilliant. Thanks, Balvinder. Just remind me how long you'd like us to take to make sure we allow time for Q&A.
30 minutes, Graham.
Brilliant. Thank you for that. So let me share my screen while I'm doing that and introduce myself. So my name's Graham Mullier. I'm based in the UK. I'm part of Syngenta crop protection R&D IT, so a very R&D centric, R&D facing organization, but part of IT. But if you dig far enough back through my history, I originally trained as a chemist. I worked as a computational chemist, cheminformatics specialist before moving into a variety of roles within IT. I'd like to talk a little bit today about Synapse, which is the internal name that we've given to our semantic search and visualization tool. It was built very much with Balvinder and Balvinder's team's help. But before I get into that, I'll just give Malcolm a chance to introduce himself as well.
Yes, hello everyone. I'm Malcolm Tone. So I'm actually the technical lead for content digitization. I think the introduction showed my background. I was an infrastructure lead previously. I've always been in IT. So now in this field for digitization and making our assets available to the business, which is very interesting. And this is where I've met Balvinder and been working with the Datavid team.
Brilliant, thank you, Malcolm. So I don't know how many of you know anything at all about Syngenta. We're a relatively large organization in the agriculture sector. And for those of you who think agriculture, doesn't that mean a farmer bouncing over a field in an old open top tractor with a bit of straw sticking out of his mouth? That might well be what some farmers do, but far more of them are driving really expensive pieces of kit to do complicated pieces of agronomy. And frankly, do utterly amazing jobs to year after year produce so much food, because obviously we all want to eat. So where does Syngenta fit in? So we are very much a science-based company. We have got a variety of parts to the group itself. I'm part of Syngenta Crop Protection, where we look at bringing forward crop protection chemicals of different sorts, either small molecule or different biological related things. But they're all about helping farmers to produce food in a safe way and to make sure that that food's nutritious. And increasingly, of course, we're all trying to do things that take care of the planet. So that sustainability angle is more and more part of what we're all thinking about. Even somebody like me looking after a team sat in IT, it's part of what I do as well with my team. So sustainable innovation is the name of the game. We're looking at not just crop protection innovation, but seed innovation. We're bringing forward biologicals, as I hinted at, and increasingly getting into precision application. But if we come back to the top right-hand corner and what I mentioned around crop protection, how do we do this innovation? So companies like Syngenta and precursors have been trying to invent things for a long time. And the more that we try and work this sort of area as a variety of companies, the harder it is to find novelty, and the harder it is to find things that are not just active, but will be active in a sustainable way. Is it reasonable to keep using some of these things? Will they work in a particularly precise way? And sometimes what we're doing is looking back into the archive. So that's the core of our use case. So why Synapse? What's the challenge? It's about this increasing need to find relevant material, relevant internal and external material to support the research phase, the earlier phase of projects, and help scientists drive innovation. So the way that we've looked at it, it's a sort of pair of challenges. So there's the digital archaeology, as one of our scientist colleagues christened it. How do you dig back through time, dig back through those reports in the report archive to find things that might be relevant and then start to tease them apart and make sense of them? But also, how do you look across a breadth of repositories or a breadth of sources to find useful material? And clearly, the further back we dig and the wider we go, the more that we're going to find information locked away. And the word's chosen quite deliberately, locked away in a whole variety of formats. So without a system like the one that we've put together, we've got thousands of hours of R&D scientists' time wrapped up simply trying to search around and work out how to find relevant information. And they use this all the way through the life cycle, from very early research, which is more where we've been focused for this particular presentation, right through later stage development and right into the regulatory function, where they're engaging with regulators like the EPA or the European regulator to gain approval for use of these new inventions that we're bringing forwards. So that's why, but what is Synapse? So lovely collection of buzzwords in here, but we are genuinely using these things. So it is a new generation of search, and it's an enterprise search. It's not a sort of narrow siloed search. It employs AI, machine learning and natural language processing techniques. And we look at how we ingest documents, typically documents from a whole range of sources, as we've suggested. We use these techniques to understand what's in the documents, to organize them, to tag them, and then to support quite sophisticated querying. So we go out to regulator sites to pull in material that they're sharing from their own work and also the work from registration activities with companies like ours. We go to academic sites and pull in research papers and summaries. And we go to a whole range of internal ones, particularly our R&D archive that goes back decades. And it's important to have these clever techniques for tagging the material, because otherwise we drown in irrelevant and unwanted material. So that's the big picture for what it is. You've got a bit of a hint for why we care. But now we want to get a little bit deeper into what's there in the core capabilities of the platform. So I'll hand over to Malcolm to cover this and a bit more of that technical detail.
Yeah, thanks, Graham. So what we wanted to build was something that was simple to use for our end users. And for that, we wanted to have some of the basic features of a search engine. So the ability to use logical operators and ors, nots, faceted filters, etc. But we wanted to go much deeper than that as well. So we want to do things like synonym searches. So to give you a little bit of context, when we go through research and development for a product, it'll start with chemists creating a chemical substance, and it'll be given an identifier at that stage. And then there are multiple stages in that research and development pipeline before it can become a product that has a trade name that can then be put on a pallet and shipped out to the farmers. So at each of those different stages, that chemical substance might get a different identifier or different registration number. So what we wanted to do was provide the facility that if you search for, say, a chemical substance like azoxystrobin, it would return all the documents that contain that chemical substance, but also documents that contain all the synonyms, all the other identifiers as well. So we managed to provide that functionality. There's some other things as well. We found that a lot of our documents contained embedded documents. So it might be we have a Word document that has an embedded Word document that in turn has an embedded Excel spreadsheet or PowerPoint. So we wanted to be able to extract all the documents down that tree. But also the important thing was to make sure that we keep that parent-child relationship as well. And as Graham was saying, a lot of our documents might be older, so we need to support things like older versions of Word, older versions of Excel, and also documents that might be scanned documents. So it might be a scanned PDF, or it might be a Word document has scanned pages within them. So we also needed to look at the optical character recognition services to digitize that content. So yeah, I think we can move on to the next slide. So what we're trying to look for are categories and concepts, and what we're trying to do is enhance our document so that we use tagging, so that we can actually search on these concepts and categories. And to do that, we're using natural language processing techniques to identify text tokens within the documents. And then we use entity extraction techniques to be able to tag those concepts and categories. And there are typically two types of extraction techniques that we use. We use model-based. So we use machine learning models, which are trained to identify patterns. And then we can say, identify things like the title of the document or the author of the document. But we also use ontology-based extraction techniques as well. So we had an existing information model, and we've got instance data that gets stored within MarkLogic within the graph database. So we can use that knowledge graph to identify the contexts and categories. And so, for instance, all these synonyms of a chemical substance are stored within the graph DB, and can refer to it there. I think it is worth noting that MarkLogic is a 3-in-1 database, so we've been using MarkLogic as a technology. It's an XML store as a graph DB, and it's search engine, so it's been very good for this particular use case. Some of the other things we need to be aware of, there's semantic disambiguation. So for instance, we've got a product called Boxer. So we need to make sure that we identify our product Boxer from somebody that puts boxing gloves on and fights, or Boxer, the breed of dog, or Boxer, even the type of car engine. So that we've got techniques, our third party use various different techniques to identify that it's actually talking about the product, Boxer the product, the Syngenta product. So if we can move on. So the solution, so how does it work? How's it set up? So if I start with the top left, we query both external and internal repositories. So this is one thing we wanted, multiple repository, one search engine. So for instance, we might pull documents from the Environmental Protection Agency, the EPA, but equally might pull documents from our internal data sources like Documentum or SharePoint. So what we've done is we've built an integration pipeline for each of those repositories. And this flows into an orchestration engine that we've built, which calls multiple microservices. So for instance, you've got there the upload API, you've got the OCR API as well. It'll call those microservices in turn, it'll enrich the XML. So it's a multiple of microservices technology, and also we use MarkLogic's data Hub framework as well to collate all that information and keep that information in a standardized, normalized format. All that work gets done in a staging database, and then the enriched XML is pushed through to the final database, where we've built several APIs on top. So we can query the knowledge graph, and we can also query the documents themselves. And then the top right, we've built a UI that the users enter their queries and get their search results. So if we can move on. So this is a screenshot of our user interface. So you can see at the top there's a query toolbar, and you can see that azoxystrobin's been put in there. We use autocomplete heavily. So as you start typing azoxystrobin, it'll give you a list of all the relevant words it could be. And you can see there that azoxystrobin has already been picked up as a chemical substance. So it's already querying our knowledge graph. The results are returned in a list underneath. They can be expanded as well. So what we can do is we can see where those query results are highlighted in the document. And then on the right-hand side, we've got various different elements. So we've got faceted searches, for instance. So we could pull in just search on the repository, individual repositories. We've got the use search synonyms there. So I was talking about those synonyms that azoxystrobin has. So there's some of the other identifiers that azoxystrobin's known by. We've got an information card. So we can run queries across some of the structured data, the databases within Syngenta. And at the top, we've got a folder option as well. So people can save their searches and we can share those searches with other users. And then down at the bottom, we're looking at visualization techniques to try and make it easier for the end user. So what you can see down there is you've got chemical substances. There's 155 concepts that have been returned by that search. So a user can drill down and he can really narrow down which concepts he actually wants to be interested in to narrow that search result. We've also got the chemical structure search as well, so users can actually enter the chemical structure and do searches on those. And then on the right-hand side, this is more in development, but we're looking at clustering techniques. So can we cluster on individual words or phrases? Again, it's all about trying to make it easier for the end user and give that really rich search experience to make the research results really relevant to what they want, and be able to put very complex queries in and get relevant results. So I think I'll hand back to you, Graham.
Thanks very much, Malcolm. Yeah, so I've got a bit of a visualization project background, so I'm really excited by where this is going with some of these developments that Malcolm pointed to, with these quite exotic pie chart type visualizations onto information clustering, document clustering. So these are some of the technical pieces that the team have built up and that we're delivering to Syngenta R&D. So if I just try and wrap this up a little bit, we've gone after sort of a quite a broad, fuzzy supporting innovation use case. We've put together a platform with Synapse that does pull quite a range of information together and has some very sophisticated tagging to make it more relevant, to give us approaches to searching that are way faster than a number of, at least our legacy systems. Maybe yours are brilliantly fast, ours are not brilliantly fast. So merely putting them in a more modern technology helps. But as somebody who's had to do it, it gets really dull running nearly the same search across 5 different silos of information. So a big leap forward for us is pulling information together so that we've got this cross-system architecture and allowing a search across the whole lot all in one go, and then taking it further. So being able to search across concept space with the knowledge graph that we've got and all the synonyms that are loaded in, not merely sets of heaps of documents, but looking across the content in there. And as Malcolm pointed out, that ability for me to search for azoxystrobin, and I find a document from 30 years ago that refers to ICIA 5504, which is an old R&D identifier for it from its development phase. All of that is really important. It is helping scientists save time. It is helping them identify things that they're finding really interesting. So to me, it looks like the project is delivering, but it might still leave you with some questions. So I'm not sure I've got a huge number of facts that might help convince you, but maybe one anecdote. So as we've been developing this, we've been working closely with the scientists, as you would imagine, and one project kicked off that wanted to do some of this digital archaeology. So it did dig back into the archives, looking at one science area. Balvinder was really helpful at helping the project team work around some of the constraints with the user interface to get to the API, to search through the material. And it, well, one of the things that it did was it left one of the scientists involved with a week's worth of reading in the run up to Christmas one year, the year before last. But he was very happy doing that because the material that had been found was very relevant. And through his reading and all the searches that Synapse had done, he and the team were able to identify a handful of molecules that had been of interest, but they'd been parked because they weren't quite what project teams 35 years ago wanted. But now they are of interest. And the whole exercise has been so successful that that particular project team won the recent internal Syngenta Science and Technology Prize. So I think a fact, but I know a pile of anecdotes don't necessarily make a very statistically valid thing, but I think that's quite a powerful one. That key scientists within Syngenta have used this system and found something very important to advance a significant digital project. So very open to answering a few questions, but I'll just pause for a moment and thank Malcolm for helping to present this and for all the technical help that he's given me and the rest of the project team. So there's a whole Syngenta project team behind this, but very much including Balvinder and the Datavid team. We couldn't have done it without your assistance. So thank you. I'll pause there.
Thank you, Graham. Thank you, Malcolm. Very good, interesting discussion, and every time I hear you talk about the business context and puts, we build technology, but sometimes we don't realize what value it's driving towards the business. So every time you share this, it's really interesting for me. I always learn new things and new facts. So if there are any questions, then please feel free to ask them through the chat, or and we can take them now. Graham and Malcolm can take them now. I think no questions at this stage. I have one question actually to ask, and maybe Malcolm or might know more. How many data sources did we actually ended up integrating on this? The external and internal data sources. Do you remember that, Malcolm? How many do we have now? It's
we might possibly have lost a connection to Malcolm. So I'll have a go at fielding it. So I think we're looking at somewhere in the region of 10 maybe different categories of data source. So we've got numerous internal SharePoint sites and Teams sites. We've got a number of internal, hideous though they are, network shares that a number of our science project teams and colleagues use. But then we've got internal document repositories, so that there must be of the order of half a dozen categories, not enumerating all the SharePoint sites. And then externally, we've gone to quite a few regulator sites. So through Europe and North America, we've gone to sources of academic journal information, particularly some of the abstracts that are there on PubMed. So in terms of big category sources, somewhere in the region of 10 or 12. If we get very fine-grained, probably more than I can count. And it means we've ended up with somewhere in the region, I think, of 35 million document type items within the system that have been tagged to one level or another.
Thanks, Graham. We have a few questions coming up now. I can try to collate them. So the total size of data, so 35 million, I think few terabytes. Can we accommodate searches in other languages? The underlying API supports it. I think we are currently, from the user interface perspective, only supporting English. But we have done some tests with, I think we tried Japanese, right, Malcolm? Or
yeah,
that worked.
Yeah, we tried one or two others. Yeah.
Yeah.
And it is a perennial problem for us. We use English as our internal language, sort of corporate language, to make it easier for teams to work with each other. But there is material that we're picking up that might be written in, let's say, Spanish, if we pick it up from a Latin American country, or Brazilian Portuguese, as well as Chinese and Japanese. And one of the things that we've got on the roadmap is, how do we deal with those? So it's less about querying in another language, but how do we tag and index the material so that we could find it more easily?
Yeah. Yeah, thanks, Graham. Another one here, how much did we customize DHF? The core framework, not at all. Not at all. We didn't customize the core framework, but we, of course, implemented our own flows. Another question, this one maybe, yeah, how long did it take to implement such a system?
Oh, well, how long's a piece of string? So there was the very first proof of concept that was done, and then there was another proof of concept that was done, and then there was another proof of concept. So this project has had a really weird gestation. It was unfortunate that it got lumped inside a relatively big transformation program that I think tripped up a little bit and had to reshape its scope, and this got left outside. So then a couple of years back, I came along. I was helping my boss to set up a team just to cover this as one of a few things in a particular area. And then we managed to have one good, quite narrow use case to focus on and drive forwards. So ignoring some of the preamble, it's taken us, what, a good 18 months to get to the point where we're now ready to launch to a wider audience, maybe getting on for 2 years.
Yeah, thanks, Graham. Another question. Sorry, I'm just reading them now. So how difficult was it to access third-party sites like EP or PubMed? So Mark, they provide APIs, so we were able to use the APIs. So it was easy. We had to, of course, write some integration to pull the documents.
Yeah, I think also we did have to, we had a third party who was scraping the web for some. So it really depends on the site, whether they've got APIs that are available.
And then adapting as some organizations changed their APIs while we're in the process of using them, or we found that we hit limits on what they were comfortable with us hitting in terms of downloads. So a whole series of issues, but once you've solved them in a couple of cases, then the ways around the pain points become quite repeatable ones.
Yeah. One more question. Can you elaborate a bit on how to define data types? What was the level of data literacy? I'm just trying to understand this question.
I'm not sure I understand.
Sure, I understand that one.
Okay, Rudy, if you could clarify that a bit, we can take it later. Can you demonstrate few actual graph documents and its ontology? I think that will require a little bit more deep dive, so we can have a follow-up session later.
Yeah.
How complex is the security model and data, and did it impact delivery of your solution?
That is a very good question, I have to say, because we've got multiple repositories, different security models. We initially took the step that if it was available to users internally, then we, then anyone on the platform could actually see them. We are working on a security model now to see if we're more confidential or more limited documents, how we support those going forward. But it's not an easy problem to fix, but we are trying to simplify that process.
Yeah, there's sort of a mismatch between how R&D wants to work to support innovation and what's been baked into some of the legacy systems that we're interfacing with, as Malcolm suggests. So broadly, what we've done is we've taken the easy route, and if any typical scientist should be able to see it, then we pull it in and we make it available to them. Stuff from public sites is easy, and then those internal ones are easy. And now we're at the point where we want to just push the envelope a little bit, but that's going to need a more sophisticated access model. But it's just the next piece of the evolution of the platform.
Yeah, thank you. I think that covers most of the questions.
Did I see one in there from Eric? Oh, you handled the one from Eric about the ontologies.
Yeah.
Yeah.
I think the only one on the Optic API from Matteo. Did you use Optic API? Did you have custom facet? Yes, we have custom facet built on triple queries. We did not use the Optic API. We didn't have to until now. I think that covers all the questions. So thank you once again, Graham and Malcolm, both of you, for preparing and presenting and sharing all the information. It's been really good. I'll move on to our next presenter, Mehdi, now. So Mehdi, over to you.
Thank you, Balvinder. Let me just share my screen. Can you see my screen?
Yeah.
Okay. Okay. So thank you very much for this opportunity. So my name is Mehdi Machou. I'm a principal solution engineer at MarkLogic based in France. So today we're going to talk about a new addition to the MarkLogic offering, SmartLogic Semaphore. So just to add a point to what the Syngenta team talked about. So there is two ways of extracting meaning from content. There is the machine learning model based techniques, and there is the knowledge-based graph techniques. So Semaphore is based on the second one. So it comes with a set of tooling, and I'm going to touch each one of them. So first, it's a really built-in tool with MarkLogic to build and manage semantic models. So by semantic models, we are talking about taxonomies, ontologies, controlled vocabularies, and business glossaries. So all those elements are managed with a portal, user interfaces that help subject matter experts to build their knowledge graph easily and build on top of it. As the Syngenta team said, they did the project by accumulating different proof of concepts, and it is really an iterative matter. So this is an ideal tool to build this kind of knowledge graph iteratively as your data is growing and your facts are growing in your company. And once you have this model and it is done on Semaphore, we can start leveraging it to enrich and extract entities and facts from it. So it's really a built-in feature in Semaphore that comes with a built-in and APIs in this case to extract content, but also interact and recommend documents. And finally, the third feature is to leverage all those APIs to build use cases like improve decision-making, improve findability, search and discovery, enhance discovery. And all those use cases are able to do thanks to the APIs that Semaphore are providing to build user interfaces on top of MarkLogic. So all that feature can be done at scale. So with Semaphore and MarkLogic, we can manage models that spans to millions of concepts, really, and you can have millions of text articles that you can process a day, and you can do it concurrently with hundreds of thousands of customers hitting to the APIs in MarkLogic. So just to illustrate all those capabilities, we did prepare a demonstration to you guys for today. And before going into the demonstration, I wanted to give you a little bit of context what we did. So the demonstration that we're going to see today contains research articles published by NIH PubMed organization. So just for those who doesn't know PubMed, so PubMed comprise more than 33 million citations for biomedical literature from medlines, life science, journals, and online books. And they are present on these portals. And these articles have content surrounding medical research and subject pertinent to that research. And you're going to leverage these contents as well as the knowledge graph that we built previously on MarkLogic Semaphore to see how we can build contextualized search application on top of MarkLogic. So just to touch a little bit of to just give you a little bit of overview of the architecture and the implementation we did in this demonstration. So everything starts with the data. Just in this case, we gathered reference data, and this information is really important to build the knowledge model graph. And we did use the tooling provided by MarkLogic Semantics to build the knowledge model management. We did combine this information with data coming from PubMed. So those are structured and unstructured documents, PDFs and Word documents that we were able to extract. And that data was ingested into MarkLogic Data Hub. So the Data Hub is really MarkLogic to store, enrich, curate this information so we can provide metadata about the data we did ingest. And we did leverage at this point, once we had the model put in place, we did leverage the classification algorithms that comes out of the box with MarkLogic Semaphore, like NLP techniques that Syngenta talked about previously, to enrich on the fly the documents with additional metadata to classify it. So in our case, we have documents related to medical, for example, medical research. We can have lung cancer, for example, but maybe lung cancer is not represented textually on the content, but since we can understand the content of the text, we can say that in this document, we are talking about lung cancer. So this kind of classification and this kind of information comes and enrich and tag the document with this metadata. And also Semaphore is providing in the consumption part APIs that will be consumed by the web application or the mobile application that we're gonna build on top of MarkLogic. In this case, we're gonna use the native search APIs that are provided by MarkLogic to search and wait and present the results. But we also leverage the APIs provided by Semaphore for present the facts mostly close to the document we did search to. We're gonna see all that in details on the demonstration. So let me switch to the application. So I'm gonna switch to the application we did build for that. And the application was built with standard web technologies, so nothing special here. And we're gonna search, everything starts with a search. We're gonna search for terms like cancer or tumors, because we are interested in those terms, and we're going to see what results MarkLogic are providing to us. Okay. Okay, based on those results, we have a different set of results that are presented to us. We have facets, and those facets help us classify the documents. So, and this information, since are coming from MarkLogic, the documents are stored in MarkLogic. So we have metadata coming from those documents, from the enrichments we did to them. So like the publication, for example, of those documents, but we have also subjects, and those subjects are really information coming from the classification step that was done inside MarkLogic to be able to extract, for example, that, for example, a document is talking about cancer or is talking about pavements, for example. So this kind of classification is automatically provided and enrich the documents. We have also search results here. And for the search results, we are presenting information about the title of the documents, as well as a preview of the most relevant information that talks about cancer or tumor in this case. And most importantly, as you can see here on the right side, are all the facts that closely relates to those documents. And this information here is coming from Semaphore. So Semaphore is providing us with the fact that are contextualized and closest to the content you see here. For example, if I focus on the lung cancer here, we see that since we did search for cancer, we have the closest fact that we found in our database and provided by Semaphore is the lung cancer with description. We even have a preview of the cancer, as we can see here. We have also information about the facts, but we have also the concept of see also, because all the information on the knowledge graph are linked. We can further explore the relationship between this fact and other related facts that you can find here. And we can even explore new documents that are related. And this concept is really powerful because based on this fact, we can recommend document related to related facts to this one. So everything is linked. So in this case, I'm mostly interested in lung cancer documents. So what I can do is click on concepts and further play on the weights of each one of the concepts. For example, I'm interested in lung concept now. So I can go to lung cancer, for example, and give him more weight than the rest. And you can see that the results are updated with the most closely related document to lung cancer. So by closing this one, you can see now the document speaks about lung cancer, medical and psychological treatments. So, and they got weighted, and we did go from 100,000 document to just 1,600. So it's a way really to refine the result based on concepts that we are mostly interested on, even if lung cancer was not explicitly written and existing on the document. So it's really interesting fact at this point. Of course, we can explore further if, for example, we are interested on seeing the content of the document. And this is really a technical representation just to show you that the document gets tagged with additional information at this point. So that's good. That's really interesting. But how did you do it? So as you can see, lung cancer, I'm going to focus on this one just to show you what we have on the Semaphore portal. So I'm going to switch to the portal right now. And as you can see here, we can have this portal that helps subject matter experts to build their models, enriched with new facts. And in our case, we are mostly interested on our model that we just worked on. So I'm going to click on models. And we can go, yeah. Let me just refresh the page. So I'm going to go to my model. As you can see here, I can see all the model I'm working on. So there is different models, but the one I'm interested on is subject. So if you go to subject in our sandbox, we can see here that we have the taxonomy that was used in this case. So in Semaphore, we can use taxonomies, ontologies, and different business-specific glossaries. In our case, it's a taxonomy. So if I focus on lung cancer, as you can see here, I can go directly to the fact that I'm interested on. And you're going to see that is related to what you did see on the UI. So this is the concepts that I showed you in the UI. This is how it is modelized on the platform, and it gets a lot of information. So it's really the description. We have multiple language support. So in this case, we have lung cancer in English, but we can support many more, almost 13 languages that we can have here. So we can support search in multiple languages around these concepts. We can also enrich those concepts with additional concepts. If I go here to side panel, to lexical resources, and I say here, okay, those are my alternative labels from my lung cancer, but what if, as an expert, want to add additional labels? You see that Semaphore suggests me other labels that can be related to this one. So it assists me in this case to further enrich my facts, like, for example, drag and drop in it to my alternative labels here and edit it and save it. And now this label is also related to these facts. So as you can see, this is really a simple and basic way of enriching facts after the ingestion. But there is also another ways to ingest it. And for those who wants to explore the relationship between the facts, there is a way of visualizing the relationship. Let me switch to the visualizer. And as you can see here at the center, we have the lung cancer. We know that it is, as you said before, smoking is a relation to the lung cancer. And as I'm clicking on to the fact, I can explore the relationship existing in the knowledge graph. And for someone who has the right to edit, he can add new facts and enrich this model further. So of course, we have more other features that we can show you, but those really are related to the demonstration we wanted to show you today. Thank you, everyone.
Thank you, Mehdi. Very good, very informative, and thanks for demoing. A lot of effort goes in preparing a live demo. Any questions any of our audience would like to ask Mehdi on his presentation?
I'll ask one if you don't mind.
Yeah, sure, Graham. Please.
Yeah.
Lovely to see that walked through. To what extent is this something that you find that an average, scientific or technically aware person might be able to pick up versus a much more specialized, carefully trained team might pick up, Mehdi?
Yeah. So in terms of managing the platform, you mean? So a lot of focus was done into the portal to make it user friendly. So this is what is interesting, because what I understand you did during your project is that there is a lot of overlap, but what brings this platform is that it automatize and industrialize the way of creating those knowledge graphs that you are using. So you have the tools, and they are quite user friendly in this case, to first ingest from the different sources you want, to work on it, evolve them, enrich it, and then explore it directly in combination with your documents. So it's really this way of operation that is easy to do in this platform, instead of developing it or coding it in different solutions, with different solutions.
Nice, thank you.
So Mehdi, we have a couple of questions. Where can I find tutorials for MarkLogic and Semaphore? There's a question from Sally.
Yeah, so we are working on a couple of publicly accessible demonstrations. So this one is in the exercise of putting it in public in the near future. So the idea is to have a couple of getting started tutorials that we are working on today, since there is now SmartLogic and MarkLogic is one company, MarkLogic now. So the exercise is done into putting those kind of tutorials and get starting to put people into testing it, our solution. So for the moment, we are working on them.
Thanks, Mehdi. Another question we have, having internal data plus public data in multiple formats, for example, ERP, specific database, documents, PDFs, how can I use them?
Yeah, so this is what makes SmartLogic and MarkLogic a powerful solution, because with MarkLogic, we already have this support of multiple formats. We support structured, unstructured document coming from CRM, ERPs, SAP, so just to name a few. And this is what's interesting, is that once you get all this data into MarkLogic, we can leverage them to create your knowledge graph. So with the power of Semaphore, we get the tools to build and modelize your relationship and entity based on this data. So yeah, if you have data, and mostly the company have this kind of data, in our demonstration, we did show DBpedia or Wikipedia data. This is public data, but for enterprise, they have their own data. Even if they are siloed, MarkLogic have a long experience of tackling this kind of use cases, and those two is really a combination to be able to get this data on and convert them into a knowledge graph. Yeah. So to respond to your question, yeah, it's possible to leverage this kind of sources.
Thank you, Mehdi. Another question from Santosh. Does the classification service require a training set, or is it rule-based?
So it's MarkLogic and SmartLogic, most precisely in this case, is working under the hood. So they are using natural language processing, so NLP algorithms that are coming out of the box from Semaphore. We are not using machine learning and training techniques to do this kind of exercise, but mostly relying on natural language processing that is in collaboration with companies that are specialized in this field, that integrate this kind of algorithm into our platform, and we are able to leverage them. So yeah.
Yeah, thanks, Mehdi. I think that covers all the questions. Have I missed anyone? Sorry, just give me a second.
Yeah.
Okay, we have one more question. How many sources and how much data transformation do you have to do? Do you have to do key on indexes? How do you feed your knowledge graph from known namespace elements or mapping of source data?
So it depends on the use case. It depends on the sources. As you can see here in the example we showed, we had just one source, which is the document. But in combination with MarkLogic, we are dealing with hundreds of sources. It depends. It can be 10, it can be 20. And we are leveraging MarkLogic Data Hub Central, which is really another kind of tooling that comes with MarkLogic to do all those transformation and prepare the data so they can be consumed by those knowledge graphs, or at least enrich the knowledge graph. So it depends of the use cases really to do this kind. So wherever it is, one or many, there is the tooling to do this kind of transformation. Yeah.
Okay, another one there. Does Semaphore intend to replace existing tools such as Data Hub Central Community Edition?
No. But there is there is two things. There is the Data Hub Community Edition and there is the Data Hub Central. And Data Hub Central now is already replaced Data Hub Community Edition. And this tool is really complementary to Semaphore. So they are complementary between them. There is no replacement between them, I would say, in this case.
Which mechanism do you use in Semaphore to deal with language ambiguity?
Yeah, so it's quite specific language in this case. For my level of knowledge, at least, I know that at the level of the algorithm that are involved in NLP, all the heavy lifting is done, I would say. So without entering into details, I would say there is the NLP language algorithm in this case that are used to do this kind of operation.
Thanks, Mehdi. I think that covers all the questions.
Thank you.
Haven't missed anyone. Okay. Okay, one more question. If Mark here, if a user adds alternative labels, are those labels exposed to other users? Is there an admin tool to clean up and manage labels?
So those additional labels that are added get persisted into MarkLogic. And once they are in MarkLogic, there is the security models that are applied to them. So you can, in this case, manage who can see them, who can use them. And depending on the consumer, the API consumer, he can have access to this custom label or not. So yeah, you have full control on additional data that you add to the platform.
And I think James has also tried to add on. He said that there is a workflow tools in Semaphore to suggest and clean terms. Thanks, James. Okay, I think we'll just give another minute if anybody wants to ask any questions. So meanwhile, Mehdi, I have one question for you. So you mentioned there is some work being done on the documentation and in the university, but are we expecting more tighter integration of smart logic with MarkLogic out of the box? Or currently you showed this architecture diagram where the documents and the data is flowing through Semaphore to be enriched. Do we expect something which will be more tightly within MarkLogic platform itself?
Yeah. So at this point, from what I heard, there is you are just at the beginning of the integration. The first step, as you can see, there is this communication between two tools that are tightly combined because they both rely on MarkLogic database as the core for the content, and there is further integration in the future to make it really a single product with the same API. So it's already the integration is en route. Yeah, so it's ongoing, I would say.
Ongoing, okay.
Yeah.
Okay, thank you very much. So I think there are no further questions. So we can all get 10 minutes back from the session. So I'd like to thank our presenters one more time, Graham, Malcolm, and Mehdi, all three of them. It takes a lot of effort to prepare such presentation and present. So thank you very much. And I'll also like to thank our audience for taking the time out and, attending the presentation. We'll be asking for some feedback in a follow-up emails to whether what kind of sessions, if this was a good session or not, and what kind of information people would like to see in the future sessions. And thank you very much. And you all, I hope you all have a very good evening. Thank you.
Thank you.
Thanks very much. Good to be able to talk and present. Thank you.
Thanks, Graham.